Okay, I'm continuing this document. Another recording, it says polynomials on top. Another recording included the first page. I will be picking up on the second page. Okay, it starts with adding polynomials. All right? So adding polynomials, you guys can see the instructions on the paper. Example, you got 2x cubed plus 5x squared plus 4x minus 7 plus 8x cubed plus x squared minus 9x plus 4. The most common method now is we no longer generally use the old vertical method. Generally what we do is we just ignore the parentheses. So we got 2x cubed plus 5x squared plus 4x minus 7 plus 8x cubed plus x squared minus 9x plus 4. Okay, so what I'm going to do is I'm going to, because there's so many terms, I'm going to be putting the like terms together to be combined. Okay, so those two are like terms because they have the same exponents. 5x squared and x squared. And then 4x's and minus 9x's. And then minus 7 and plus 4. We don't change the exponents in this context, we're only adding. Okay? So if I got 2x cubes and I add 8x cubes, that gives me 10x cubes. So 2x cubes and 8x cubes is 10x cubes. 5x squareds and another one is 6x squareds. 4x's lose 9x's is minus 5x's. And then negative 7 plus 4 is minus 3. That's it. We're done. Okay? Subtraction. Example. We got 8x cubed plus 7x minus 4 minus 6x squared plus 2x minus 1. This negative is going to be multiplied by everything in the parentheses. So you will have sign changes galore. This is going to be 8x cubed plus, because there's a skip power of x here, going from 3 to the first, x cubed to x to the first, I'm going to leave space here. This will be plus 7x. This will be minus 4. Then over here, because of the minus, you'll have minus 6x squared, minus 2x, and plus 1. Because of the sign changes. Why the sign changes? Remember, you're multiplying by a negative. Okay? So, you'll have 8x cubed, and then the minus 6x squared, because we like to write these in descending order. 7x's take away 2x's is 5x's. And then a loss of 4, gain 1 is a loss of 3. Okay? So that's how subtraction works. It's changed the signs of the second polynomial and combine. Okay? We don't use the old vertical method anymore. That's rare to be seen. So I'm going to get this off the board and start talking about multiplication. Okay, so switching over to the third page, multiplying polynomials. So the example that I have with a monomial times a polynomial, a multi-term polynomial, is you're going to multiply all three terms by it. So 5 times 2 is 10, and then when you're multiplying, you add the exponents. 3 plus 2 is 5. 5 times 4 is 20, and x cubed times x is x squared, is x to the fourth. And then 5 times minus 7 is minus 35 times the x cubed. That's it, okay? So that is a single term monomial times a multi-term polynomial. Next, I'm going to talk about the most common types of problems you will encounter, and that is multiplying binomials by binomials, 2 terms by 2 terms. The method is generally to use what's called the FOIL method. Okay? This stands for multiplying the first terms, the outer terms, the inner terms, and the last, and then combining like terms as applicable. Okay? So the first terms here are 5x squared and 4x. The outer terms are 5x squared and minus 3. The inner terms are 2 times 4x, and the last terms are 2 times minus 3. Okay, so first, outer, inner, and last. And then we're going to do these 4 multiplications and combine if as applicable. So that will be 20 x cubed. This is minus 15 x squared. This is 8x. Now it's positive, so we're going to use a plus to describe it. And then 2 times minus 3 is minus 6. Adding negative 6 is the same as subtracting 6. So that's 6. Okay? You don't need to be that laborious about it. I just decided to be that laborious about it this one time. Okay, with example 2, at this level, you should be able to do most of these multiplications in your head. Okay? All right. So example 2, starting on the next page. Three x minus 4 times 2x minus 5. First, outer, inner, last. First terms, 3x times 2x. 3 times 2 is 6, and x times x is x squared. Outer terms, minus 5 times 3 is minus 15 times the x. Inner terms, minus 4 times 2x is minus 8x. And then the last terms, negative 4 times negative 5 is positive 20. These are like terms, so we will combine them. 6x squared minus 23x plus 20, because a loss of 15x's lose 8x's is a combined loss of 23x's. All right, so I'm going to be getting these 2 off the board. Actually, not yet. Let's see if I can't get this tilted just perfect. Okay, now I'm going to move over here. I'm going to skip examples 3 and 4 and talk about example 5. Example 5 is x plus 5 squared. That is equivalent, It's not x squared plus 5 squared. It's not that simple. This is equivalent to x plus 5 times x plus 5. And that has to be multiplied out. So F-O-I-L. X first terms are the x squareds, or x squared. Outer terms, 5 times x, so plus 5x. Inner terms, plus 5x. And then the last terms, 25. These are like terms. 5x's and another 5x are 10x's total. Okay? Do not give me just x squared plus 25. That's mistaken. You actually have to multiply the whole thing out. Finally, example 6. X plus 3, x minus 3. The only difference between these two binomials is the sign in the middle. And when that happens, something interesting happens. If the only difference is the sign in the middle. First terms, x times x would give me x squared. X times minus 3 is minus 3 times x, minus 3x. Inner terms, 3 times x, so plus 3x. And then the last terms, 3 times negative 3 is negative 9. Those cancel. That's 0. So the only thing you're left with is the x squared minus 9. Okay, so that is what happens when you multiply binomials. That's 2 terms by 2 terms. So I'm going to get this off the board and start talking about what happens when you've got more than 2 terms at a time. So now we're talking about general polynomial multiplication. Okay? General polynomial multiplication. I'm going to use example 1, and then that's the only one I'm going to use. We're going to do x minus 3 times x squared plus 5x minus 2. So the method I follow personally is, and there are other ways to do this, but the way I personally do it is I take the short polynomial times each term of the long. So this one has 2 terms, this one has 3 terms. This is the longer polynomial. So I will take each term times the binomial. And then 5x times the x minus 3. And then the minus 2 times the x minus 3. The reason I do it that way is because whenever I'm done multiplying, the like terms are right next to each other. Okay? So, distribute x squared times x is x cubed. X squared times minus 3 is minus 3x squared. Multiply, multiply. That's going to be 5x squared. That's going to be minus 15x. Okay, the whole negative 2 gets distributed. So that's negative 2x and then plus 6. And then we combine our like terms. X cubed, and then minus 3x squared plus 5x squared, well, that leaves a gain of 2x squareds. Okay? Minus 3 plus 5 is plus 2. Minus 15x's, take away 2 more is negative 16x's, and then plus 6 is the only one of its kind. So that's what happens whenever you've got more than 2 terms being multiplied. Okay? Let me get this stuff off the board. I'm going to talk about the last page. Last page is dividing polynomials by monomials. So dividing by monomials. So, example 1, 10x to the 9th plus 15x to the 6th over 5x squared. I will also be talking about example 4, 5h cubed x squared plus 6hx plus h over h. So, 10x, that's 9 by the way. We divide each term by that monomial. Okay? So, 10 divided by 5 is 2, and then when we're dividing, we cut the powers of x down to 2. So 9 minus 2, x to the 7th. And then 15 divided by 5 is 3. X to the 6th divided by x squared is x to the 4th. The powers of x go down 2. That's it. You're done. Now for this one, we're dividing by h to the 1st. So all the powers of h go down 1. So this will be, the 5 will be unaffected. This will be h squared. X squared will be unaffected. On this one, the 6 is unaffected. The h's cancel. And the 6 is unaffected. On the last one, the h is completely canceled. However, we're assuming that h does not equal 0. So we're dividing something by itself. Anything divided by itself is 1 besides 0. So if h doesn't equal 0, which is what we're assuming, h divided by itself would leave you 1. Okay? So if everything cancels under division, you have to leave a 1. Okay? That wasn't necessary here because you still had 6x. So you still had 6x. 6x times the 1 would have left you 6x. But here you have to state the 1 because that's all that's left. Okay? That's it for this handout.